Good afternoon everyone. My mini project title is Design and Development of a CPW Monopole antenna for future applications. This antenna is an expand frequency range from 8 to 2 GHz and it is used in satellite communications. The polarization I have chosen is circular polarization. Generally for satellite communication, linear polarization and elliptical polarization will not work. Only circular polarization will be having signal smooth mode. So my objective is to design a CPW antenna with circular polarized in expand applications. AMC reflector unit cell for this CPW antenna to enhance the gain parameters. My first element structure, it is a symmetric CPW monopole antenna with no coil included, and second step I have included a defective ground structure in coplanar waveguide. Next I have introduced a coil to convert the linear polarization to circular polarization. Next I have introduced a slot in between ground plane to enhance the bandwidth parameters from 8 to 12 GHz frequency range. And next, the axial ratio enhancement is placed due to a coil introduced in the left side of the arm. And next, the advantages of using AMC, it controls the phase reflections, and also the performance of the antenna gain is very good compared to normal CPW. Coming to results, for AMC reflector, after using AMC reflector with single antenna, I got a dual band in X-band frequency range 8 to 12 GHz with a return loss of minus 25 dB, and also the gain is around 9.5 dB gain at two operating frequencies in both side direction. The unit cell AMC reflector is exactly matching with my single element CPW antenna at 8 GHz frequency range. Single element CPW antenna. The frequency is around 8 GHz frequency range, operating frequency range. And you can see the gain versus frequency plot here. The gain is gradually increasing around 14.3 dB to. Without AMC reflector, I got around 6 dB. With AMC reflector, I got around 14.4 dB. And axial ratio versus frequency graph, you can see with and without AMC reflector. After using AMC reflector, I got around 3 GHz axial ratio bandwidth. Here you can see the polarization we have actually used around circular polarization with less than 3 dB axial ratio. Finally, I conclude with high gain, wide bandwidth and circular polarized CPW monopole antenna for CubeSat application, and I got an expand of two operating bands. Around 8 to 9 GHz is one operating band at 8.23 GHz operating frequency with the impedance bandwidth of 17.5%. And the peak gain is 14.8 dB. And the axial ratio bandwidth is 33.16%, and it is covering entire operating frequency band. And proposed antenna is used for expand CubeSat applications.